Today we're going to talk about modeling inverse and joint variation. You have done direct variation. We did that last semester. Direct variation looked like y equals mx plus b, except for there was no b. You just had an a instead, so you had a slope. Now we're going to do inverse variation. And the difference here is that instead of ax, we have a over x. A can't be 0 because then you just have y equals 0. When we talk about a is called the constant of variation. We're also going to talk about joint variation. And it looks kind of like direct variation, except we can have more than one letter. So we still have a, our constant of variation. And we have more than one letter going on here. It could be 2 or more. So example 1. Tell whether x and y show direct variation. So that was y equals ax. Or if we have inverse variation, that would be y equals a over x. Or neither, which would be if we had something that looked like that, except it would have maybe a b. It would have a y-intercept. So let's look at these. Well, none of these, kind of off the top of my head here, look like they are in that form, y equals ax or y equals a over x. So let's get y by itself. So for this one, I'm going to divide both sides by x. And I have y equals 7 over x. So that looks very much like what we have over here. So this is inverse variation. If somebody asked, our constant of variation there is 7, because that's what a is. Looking at number 2. That plus 3 is a tip-off right away that we have no direct, indirect variation here. This is just going to be neither. There's nothing I can do with that. This last one, well, it kind of looks like inverse variation, but y isn't by itself. I have to get y by itself first. I'm going to multiply both sides by 4. So I have y by itself, and now I have y equals 4x, so it tried to trick us. This very much looks like y equals ax now. This is direct variation. So we have our we're going to do the same thing for these next 3, so see what you can do. Let's take a look at what you got. So we have, for this one, we need to get y by itself. So y equals 3x after we add 3x to both sides. We don't have any plus or minus outside there. It looks like y equals ax. This one over here kind of looks like inverse variation, but y isn't by itself. So let me make sure I have this right. So let's multiply y by both sides because y needs to be in the numerator. So I have x, y equals 3. Divide both sides by x to get y by itself. And then y equals 3 over x. Our constant's up there in the numerator, so that would be inverse variation. The last one, let's get y by itself. subtract x from both sides, so we'll have negative x plus 5. That's got a plus or minus outside here, so that's going to be neither. Just as a side note, if you had something that said y equals x over 3, that's not inverse variation. We need to have the constant on the top in order for that to be inverse variation. So this would be y equals 1/3 x. And this is actually direct variation with 1/3 being our constant of variation. Okay, example 2. Let's see what we've got going on here. Now we have words and they want us to turn them into math. So the variables x and y vary inversely. Okay, I know what that means now. That means y equals a x. And y equals 7 when x equals 4. Okay, that's good to know. Write an equation that relates x and y. Okay, so they want me to write an equation. And then they say, then find y when x equals negative 2. Well, I kind of have an equation. The only thing I don't know is its constant of variation. So I'm going to plug in x and y and figure out what a is. So 7 equals a over 4. I plug in y. I plug in my formula up here, in my inverse variation. Now I'm just going to figure out what a is. Well, to figure out what a is, I'm going to multiply both sides by 4. Divide a equals 28. My formula for inverse variation for part 1 y equals 28 over x. So part 2 says, find y when x equals negative 2. So let's plug in negative 2 and figure out what y is. So if our formula is y equals 28 over x, let's put negative 2 in for x. And we have y equals negative 14. And we're done. Try the same thing for the next one. Okay, let's see what you did. So you should have, again, y equals a over x. We're going to plug stuff in. So we'll get 1/3. Well, we need to get a by itself, and I know how much you guys love fractions, but we need to do is multiply by reciprocal. Do the bottom and do the top. Cancel. So I have 15 equals a equals, divide both sides by 3, a equals 5. So let's plug that into y equals ax. So our answer is y equals 5. We have just written an equation that relates x to y. Second part says find y when x equals negative 10. So we're going to plug negative 10 in for x. So we have y equals 5 over negative 10. That should come back in a minute. 5 over negative 10, that's a fraction that we can simplify. So y equals negative 1/2. There we go. And we're done. Okay, example 3. The variable z varies jointly, we get to try one of these, with x and y. So z equals negative 75 when x equals 3 and y equals negative 5. Write an equation that relates x, y, and z. Then find z when x equals 2 and y equals 6. So we have a lot of stuff to do here. We need to write our equation. And we need to find z. So varies jointly means we're going to have z equals a x y. We know z equals 75 when x equals 3 and y equals negative 5. So just like the previous example, we need to find a. So we're going to plug all that stuff in. So we have 75 equals a times 3 times 5. So negative 5 equals negative 15a. Offset by negative 15. And we'll get a equals 5. So the question was, write an equation that relates them all. Well, now we can do that because we have an a. So equals 5. Part 2 says, find z when x equals 2 and y equals 6. So let's plug it into this formula that we found. So z equals 5 times x times y. So z equals 5 times 2 is 10 times 6 is 60. And we're done with the second half. Try the next one on your own. Jointly. So we're going to tell us what to plug in. So we plug in. What A is. So A is going to be negative 3. And since A is negative 3, that means our equation is A equals negative 3xy. Part given this equation, find z. X is 7 and y is 2. So what is z with our equation with x is 7 and y is 2? We have z equals negative 21 times 2 would be negative 42. And we're done. Last example we're going to do is we are going to take words and turn them into math. So they've given us a bunch of phrases, and we're going to turn these phrases into equations. So, first one, y varies inversely with x. Inversely, that tells me that I'm going to have a in the numerator. For all of these examples, I don't have an a, they don't tell me what it is, they don't tell me how to find it, so I'm just going to write a. So y varies inversely with x, so y equals a over x. Next one, z varies jointly. Jointly tells me I should have more than one variable coming up. So z varies jointly with x, y, and r, so z equals x, y, a. Don't forget your a, don't forget your constant variation. X, y, there we go, x, y, r. Next one, y varies inversely, so I should have a denominator again. Oh, the square of x, so it's getting a little bit more complicated, but we can still do this. So y equals a in the numerator, in the denominator, not just x, but the square of x, so x squared. In the denominator, part D, z varies jointly. Okay, jointly tells me again I should have more than one variable. So z varies jointly. Z equals a, don't forget your constant of variation, and t with t and r. Then it says inversely with x, so x is going to be in the denominator. We can do both at the same time. So we have a over x, and we have a dr, so we have jointly and inversely all in the same equation. Last one, x varies jointly. Okay, again, we have more than one letter going on here, so x equals a, don't forget your constant of variation, tr, so we write t, r, and now we're going to do inverse again, inversely with s. Okay, try some examples on your own, see what you can do. Let's see how you did. So we should have, means I should have a denominator, r equals over x. Varies jointly, I should have more than one letter. So z equals a x and the square root of y. Look at them being tricky. P varies inversely. So P varies inversely, so we need a denominator with the cube of q. Cube of q means q cubed. M varies directly. With the square of n, so don't forget my coefficient. With the square of n, so n squared, and inversely with p, so I need p down here in the denominator, is inverse m. Last one. So z varies jointly, so we have more than one letter, and inversely, we have that in the denominator, square of w. And that's it. You have math Excel tonight, and you're going to get some practice.